Hey, welcome back. In this video, we're going to work on animating our nebula hazard, which means we're going to have to create some animation variables for the nebula, just like we did with Scarfy. Now, we're also going to need to update the animation frame so that we're selecting different sprites from that sprite sheet that contains our nebula sprites. All right, let's get started. Now, we've already created our texture 2D, our rectangle, and our vector 2 for the nebula, as well as a velocity. And all of this allows us to draw a nebula to the screen, but we're only drawing a single sprite from the sprite sheet. So we need to be able to cycle through sprites in the sprite sheet, and that's going to require a few more variables. We're going to need to know which animation frame we're using. This determines which sprite from the sprite sheet we're going to select. We're also going to need an update time. This will be how much time should pass between animation frames. With Scarfy, we used 1/12 of a second, so Scarfy's animation frames update 12 times per second. The nebula will need its own update time. And we'll also need a float to keep track of how much time has passed since we've updated the animation frame for the nebula. So the nebula will have its own running time variable as well. Now, once we have these variables, we can use them to animate the nebula. So your challenge is going to be to create these animation variables for the nebula. You'll need to create the following: an integer called nebFrame. This will be the current animation frame that we're using for the nebula. We'll need a const float called nebUpdateTime. Go ahead and initialize this with 1/12, just like we did with Scarfy. Create a float called nebRunningTime, and this will be used to keep track of how much time has passed since the last animation frame update. Now, once you've created these variables, go ahead and update the nebula's animation frame. Take a look at the way we update Scarfy's animation frame and use that as a guide. Now, there is no is-in-air check for the nebula, so we don't need to check that when updating the nebula animation frame. Pause the video and do this now. Okay, so we're back here in dasher.cpp and we're ready to add the nebula's animation variables. Let's go ahead and add a comment here that says nebula animation variables. Now we need an integer called nebFrame. So I'm going to create an int nebFrame. And we'll need a const float called nebUpdateTime. And we're going to initialize this with 1.0 divided by 12.0. And finally, we need a float for the nebula's running time called nebRunningTime. So we have these nebula animation variables. It's time to put these to use by animating the nebula. So let's go down to where we're updating Scarfy's animation frame. That's going to be here where we check whether or not Scarfy is in the air. Now, remember, we don't need to check if the nebula is in the air, so we're not going to have an is-in-air check. So for the block that we have for Scarfy's animation code, we're going to add a comment and say update Scarfy's animation frame. And below that, we'll add a comment saying update nebula animation frame. So taking a look at Scarfy's update animation frame code, the first thing we need to do is update that nebula running time using delta time. So we're going to do that. We're going to say neb running time plus equals dt. Okay, so we're updating neb running time using delta time, and we need to check to see if it's time to update the nebula's animation frame. So we're going to check to see if neb running time is greater than or equal to a particular value. What is the value we're checking against? That's right, it's neb update time. As soon as neb running time is greater than or equal to neb update time, it's time to update the nebula animation frame. Now, if it's time to update the nebula animation frame, that means we need to set nebula running time back to 0. So neb running time equals 0.0. Now, looking at Scarfy's animation code, we're getting Scarfy's rectangle and accessing the x variable of that rectangle. We're then using the frame integer times the width of a Scarfy sprite, and this will determine which sprite from the sprite sheet we're using. We're going to do the same thing with our nebula. So we're going to take the nebula's rectangle called nebrec, and we're going to assign a value to the x. What exactly are we going to assign nebrec.x? You got it. We're going to get the neb frame, and we're going to multiply by the width of a nebula sprite. And we stored that width in the nebula rectangle. So we're going to get nebrec.width. Okay, so we've now assigned a value to nebrec.x. We need to take the nebula's animation frame variable and update that. So we're going to say nebFrame++. And we also need to check to see if nebFrame has reached a certain value, just like we did up here in the Scarfy animation code. So we're going to check to see if nebFrame is greater than a certain value. What value are we going to use here? Well, if we look at the nebula sprite sheet, we'll see that it's an 8x8 sheet, meaning there are 8 nebulas across and 8 nebulas down. Now we're only using the top row here, and our neb frame integer is 0 when we're using the first nebula sprite, and it's 1 when we're using the second nebula sprite, which means when we're using the 8th and final sprite on the top row, our neb frame variable is 7. Now, as soon as we increase that neb frame variable to 8, it's time to reset it back to 0, which means when neb frame is greater than 7, in other words, it's reached 8, it's time to set it back to 0. So we're going to say if neb frame is greater than 7, then assign a value of 0 to neb frame. All right, we now have the animation code for the nebula. Let's go ahead and hit run and start debugging. And there goes the nebula, and it flew by really quickly, so I think we might want to change the nebula velocity. Let's scroll up to nebvel. So instead of a value of 600, let's use a value of, say, 200. Let's see how this looks. And there it goes. That looks a lot better. And you can see that the nebula has animated. Excellent job. So in summary, we've created the nebula animation variables that we needed in order to update the nebula's animation frame. We animated the nebula hazard using code similar to Scarfy's, although we didn't use an is-in-air check because the nebula doesn't use an is-in-air variable. So now that we have an animated hazard, it's time to start thinking about how we can have multiple nebula hazards in the game. And we'll cover that in the next video. I'll see you then.